Hey guys, Mrs. Phillips here. I'm going to try to go through section 8.2 notes briefly because I can't send a 20-minute long video. It might be a little bit shaky because I'm going to go back and forth from a stand into my hands just to focus in on things a little closer. So what we're going to talk about today are trig ratios. Nothing to be afraid of. I know you've heard of trig before and it's scary in your minds, but it's really not bad. The main thing to remember is it deals with right triangles, just like everything in this unit has dealt with. Trig ratios are just ratios of sides of a right triangle, okay? And then you have the three ratios. You have sine, you have cosine, and you have tangent. And the definitions are over here. And if you look, there's a triangle over here. Oops, it's not a completed triangle. There you go. And it's triangle QP, and this is an R. Got cut off a little bit. And when we're talking about right triangles, obviously you guys already know you have the hypotenuse, which is right here, and it's always there, straight across from your right angle. And then we have the two legs, and in this case, one of our legs is lowercase b, and the other leg, is going to be lowercase a. Okay? So, if you notice the definitions of sine, cosine, and tangent, sine is an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So, when you're using trig functions, in particular sine in this case, you're always going to take the sine of an angle, whether it's angle P in this case, or the sine of angle Q, which is over here. And notice I never say the sine of angle R. That's not an option because these two angles here and here are the non-right angles. Okay, so I'm going to make note of that. These two angles are non-right. So you will never use the sine of a right angle or the cosine of a right angle or the tangent of a right angle. We won't have to worry about doing that. When you look at the definitions, okay, in this particular definition, it says the sine of angle P is the leg opposite angle P divided by the hypotenuse. Okay, so if we look at our picture over here, I like to look at angle P then as my reference angle. Okay, so here's my reference angle right here, and I'm going to circle it. See, angle P is here. I circled it down here, right? And the sine of that angle is going to be the leg opposite that angle divided by the hypotenuse. If we stand at this angle here, pretend like you are part of this triangle and you're standing at angle P, the sine is going to be the leg that's straight across from angle P. Okay, so the leg, and remember there's only two legs in your triangle. Let me mark those. You have a leg here and a leg here. The sine is going to be the leg opposite angle P, which is straight across, and in this case is A. So the opposite leg is A over, and then obviously the hypotenuse doesn't change. It's always across from the right angle. So we'll put a C right there. Okay, so the sine of angle P is A over C. The sine of angle Q, now Q is a different reference angle. It's up here. We have angle Q, and it's going to be the leg opposite angle Q, which notice it's different than the leg opposite angle P. So we have B over the hypotenuse, which in this case is still C. Back up a little, right? When we deal with cosine, the cosine of an angle is the ratio of the length of the leg adjacent to the angle to the leg of the hypotenuse, so over the leg of the hypotenuse, length of the hypotenuse, sorry. So remember, adjacent just means next to, okay? So the cosine of angle P, now again, angle P is going to be my reference angle, is going to be the leg that's right beside angle P. In this case is B. So I would put B right here. And the hypotenuse again doesn't change, it's C. Right? And when I'm talking adjacent, remember, I mean next to. If you're standing right here, hello, Oh, there you are. If you're standing right here and you turn sideways and look at the leg adjacent to you, it's going to be side B. That's how I get adjacent there. And the cosine of Q, now your point of reference changes, is going to be the leg next to angle Q. Okay, so that would be A over the hypotenuse, which is C. So I will write A over C. Whoop. All right. So the cosine of P and the cosine of Q, and again, remember, these are our non-right reference angles, and I always circle my reference angles in my picture when I'm doing these problems because it makes it a lot easier. All right, the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So again, if I'm looking at the tangent of P, P is my reference angle, I'm going to do the opposite leg, or the leg opposite angle P divided by the leg adjacent to angle P. So if you look at our picture, the leg opposite angle P, here's angle P, if you walk straight across, that's A, divided by the leg adjacent to angle P, which is B. So my ratio would be A over B. There it is. And then the tangent of Q is going to be the same ratio, but different sides. It's the leg opposite angle Q divided by the leg next to or adjacent to angle Q. And remember, it's a leg, not a hypotenuse. Leg is different than hypotenuse. So look over here. Here's angle Q. The leg opposite angle Q is B. The leg adjacent to angle Q is A. So B over A. And tangent does not use hypotenuse at all. So I will write B over A right here. All right. So those are my trig ratios. And there is a really nice acronym to help you remember this. And the acronym looks like this. I'm going to write it right here. It is SOHCAHTOA. Okay, so sine is the opposite leg over the hypotenuse. Cosine is the leg adjacent to the angle over the hypotenuse. And tangent is the opposite over the adjacent. Some teachers also write it like this. They write, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I've seen it written like that, but it's still SOHCAHTOA. SOHCAHTOA. Right? This will become your new best friend because you're going to use it all the time. Okay, so real quick, here's an example. It says write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. So the sine of R. So when we look at our triangle, we have a right triangle. You can only use trig functions when you have a right triangle. R is going to be my reference angle. So here's R. R is my reference angle over here. Right here, I have my hypotenuse because it's opposite the right angle. And then sine is going to be the leg opposite this angle. So that would be 12 over the hypotenuse 13. So sine is going to be opposite over hypotenuse, which in this case is 12 over 13. It says write it as a fraction and then write it as a decimal. And 12 divided by 13 is approximately 0.92. Okay. Cosine is the same idea. Cosine of R, instead of opposite now, it's going to be the adjacent leg over the hypotenuse. So over here, I'm going to say it's adjacent over hypotenuse, which is 5 over 13. And that divided out is about 0.38. And tangent of R is going to be opposite over adjacent, which in this case, again, R is my reference angle, so I have opposite, which is 12, divided by the adjacent side, which is 5. And that's approximately 2.4. All of these examples are in your book too, so you can look at these examples that I'm doing here and you can glance at your book and try some. Okay, so that's the first part. Second example is the exact same thing. You would just write your ratios of your trig functions. One thing I'm going to point out to you guys is it says here when using your calculator, it must be in, and if you have this calculator right here, this is my son's, if you have this calculator, you will notice up here it says DRG, okay, and that is the mode. And when you hit that button, see how it has DEG, RAD, and GRD. You want this one to be underlined. So this little arrow will obviously move it to the different selections. You want DEG to be underlined, and then you can just press enter and you're back to good. Another thing to look at, it's right there, DEG. Oh, there's my phone. You can see it reflecting. Okay, here are your trig functions on your calculator: sine, cosine, tangent. And you'll notice as soon as you plug it in, one of them in, it automatically puts parentheses. So that's how you're going to use your trig functions on here. So always make sure your calculator is in degree mode. It's super important. And then it's very simple to plug these into your calculator. Remember, the angle always goes right after the trig function. Okay, there's a repeat here. Number 1 and number 4 are exactly the same. You don't need that one. And this is going to give you the answer of the cosine of 76 degrees. And this is going to be the ratio of the lengths of the sides. So you don't know the lengths of the sides, but the calculator will use this information to figure it out. So you would just take your calculator. It says cosine of 76. You'd literally hit cosine, type in 76, close your parentheses, and hit enter. Ta-da! 0.243. Hopefully that's the right answer. I guess I should check my answer page. Yep. So 0.243. What's it say? To round to the nearest hundredth. Okay, so 0.24. You would do the same thing with tangent. So tangent of 82. Enter 7.12. And then sine of 90. Sine of 90 is kind of weird. Oops. This is not wrong. Remember I said you don't normally take sine, cosine, or tangent of the 90-degree angle. If you do, in this case you get 1. If you do it over here, tangent of 90, and hit enter, you'll notice I get domain error, and that is correct because the tangent of 90 is undefined. Okay, so that's that in a nutshell. Okay, so I'm going to give you some assignments. I may put another little video up, but at least you can kind of try this beginning part of trig. And do your best, and let me know if you have questions. Thanks, guys.